Hello dear students, welcome back to physics online session. So today we will be focused on that how to find that effective resistance in case of that infinite network. For example, in that given network, if that infinite number of resistance are present, then how to find that effective resistance in case of that infinite network. So before going to start up about that infinite network, so let's focus some complex circuit here. So as we discussed in that previous class, so about that symmetry. So in case of symmetry rule, I can solve that complex circuit by mirror symmetry as well as by folding symmetry. By taking use of those, I can simplify the circuit here. So let me consider one more examples related to that. So in that given circuit, so number of resistance are there, so I am not able to count it here. So just I want to find out that effect resistance between A and B here. So in order to find that effect resistance between A and B, so now look at here, is there any possibility of symmetry? So for example, if I take like so there exists a mirror symmetry here. So here there is a possibility of mirror symmetry. So exactly if I make half here, so total resistance is R. So if I take like so, this becomes R by 2 and R by 2, and here also R by 2 and it becomes R by 2 here. So now look at here, here resistance R term is there, here are and here are, and here also R term is there. So there exists a mirror symmetry here. So left hand side terminals are same as that of right hand side terminals here. Now left hand side terminals I can rearrange here. So look at here, in order to rearrange, so this point I will take it as C1, this one is C2, and let it be this one is C3 here. Now this is point A. So from point A, here that one resistance is there, that is R here, and so from here R by 2 is there. So what's that resistance? Another resistance is R by 2. So that will connect to C1 here. Now from C1 to C2 here. From C2 to here, one more resistance is there. Shall I take here? So that resistance is C here. Now A to C2, one more resistance is there from that point A to C2. So just I will take another resistance R here, and from C2 to C3 I will take, so C3 to here, so one more resistance, so that is also R by 2 here, and so from that one again point A to one more resistance, so that is R here, and one more C2 to here, so C2 to here, one more resistance I will include here. So this is how I can rearrange that left hand side terms here. So now look at here, what is the nature of combination between R2 and R here? So look at here, so this is one point and this is one point. These two resistance are connected between two common points, so that is nothing but parallel combination, that is R of P is equal to R1 into R2, R by 2 into R divided by R by 2 plus of R square by 2, 2R plus of R, so 3R by 2 here, 2 term will getting cancelled out, so that is R by 3 here. Instead of 2, I will take it as single resistance. So look at here, instead of 2, I will take it as single resistance. What that single resistance value here? R by 3. Now look at here, what is the nature of combination between R and R by 3? So these two are in series combination. Let it be R plus of R by 3. So 3R plus of R. So that is 4R by 3 here. So 4R by 3 ohm. So instead of 2, I will take it as single resistance here. I will take it as single resistance. What its value here? 4 by 3R. So similarly, so upside same connection is there. Instead of 3 resistance, just I will take it as single resistance. So its effective value will be 4R by 3. Now look at here, what is the nature of combination here? 4 by 3R, R and 4 by 3R. So that is in parallel combination. So 1 by R of P is equal to 1 by R1, 1 by 4 by 3R. So 3 I will take it into numerator, plus of, so this one is 1 by R, or I can take it here, plus of 4R by 3. So if I take that LCM here, so 3 plus of 4 plus of 3 here. So that is 10 by 4R. So what is the value here? 1 by Rp is equal to 10 by 4R, or you can take that. So 5 by 2 here. 1 by Rp is equal to 5 by 2, or Rp is equal to what? So R of P is equal to 2R by 5 here. So what is the value of R of P? So instead of 4, means instead of 3, I will take it as single resistance. So look at here, instead of all the resistance, I got that single resistance. So that is 2R by 5 here. So that is 2R by 5. So exact duplicate is there. So that is also what? So that is also, so this one is C2, means, so for right hand side also you will get the same thing. So that is terminal B. So that is also 2R by 5. So both are in what? Series combination. Finally I will get that effective resistance here, 2R by 5 plus 2R by 5. So 4R by 5 here. So what is our answer here? 4R by 5. So this is the effective resistance between A and B. So hope you got these things. So we'll look at, okay. So now look at the circuit. So find the effect resistance between A and B in that following 3 circuit here. So look at here. So this is point A and this is point B here. So in order to solve such kind of circuit, for my simplicity, so just we can take that. So point A is nothing but a potential V. So point B is nothing but a potential 0, means from higher potential to lower potential. Between these 2 points, all the circuits are getting connected here. So look at here. So here that point B is there. Here point B is touches here, means so there is no circuit element here. So this is also potential 0. Here also potential will be 0. And here also potential will be 0 here. So here that there is no connection. Here gap is there. So here I will take one point, that point as X here. So between V and X, so one more resistance is there. So for example, so this circuit I will rearrange here. So for example, 2 points they given, A and B here. So what are those 2 points? A and B here. At point A potential is V and at point B potential is 0 here. Between these 2 points only all the resistance are connected here. So let me take one more point here. So that is point X here. A to X1 resistance is there. So that resistance will be R here. So now look at here. X to O, one resistance is there. So X to O or X to B, whatever. So this is point B, means here potential is 0 at all the points. Here there is no circuit element, means so here also 0 potential, here also 0 potential, and here also 0 potential. From X to O, one resistance is there between the same point. So again from X to O, one more resistance term is there. Same point means that is nothing but parallel only. Next one, from X to O, one more resistance is there. So now the circuit seems like easier here. So now look at here. I want to find out that effective resistance here. So look at here. In order to find that effect resistance between the point A and point B. So what is the nature of combination between R and R here? So these 3 resistance, first one, second one and third one, these 3 resistance are in parallel combination. So 1 by Rp, so that is equal to 1 by R plus 1 by R plus 1 by R. So that is 3 by R. 1 by Rp is equal to 3 by R. Or you can take that R of P is equal to R by 3 ohm. So instead of taking 3 resistance, I will take it as single resistance. So that single resistance value is what? R by 3 ohm. Now look at here, R and R by 3. So these 2 resistance are in series combination. So R of S is equal to R plus of R by 3. So 3R plus of R, 4R by 3 here. What is that? Effect resistance between the point A and B here. Effect resistance between A and B is 4 by 3R here. So hope you get this one. So look at here. Now in that second circuit, so the given point A here and point B is here. So now let me rearrange this circuit here. So in order to rearrange that, so I will take that potential point here. So for my convenience, just you will take one potential point, so then easily you can able to find here. So this is point A, so this one is point B, so point B is connected to this point, so point B means zero potential, point A means maximum potential V. So between B and this point, so there is no circuit element, so potential here also 0, here also same potential 0, here also potential is 0, here also potential is 0. Now I will take that 2 points here. What are those points? So that is point A and point B here. So look at here, between A and B, or you can take that point A is nothing but maximum voltage V, point B is nothing but 0, so that is minimum voltage. Between V and 0, one resistance terminal is there, V and 0, one resistance terminal is there, so just I will take R here. And next one, between V and 0, one more resistance terminal is there, so this is point V, so this is point O, again I will take one more resistance here, like that. Between V and 0, one more resistance is there, so between that V and 0, so similarly, so this is also between V and 0. Now the circuit is simple. So these resistance are in parallel combination, so then R of P is equal to what? R by 4 ohm. What is the effect resistance here? Effect resistance is R by 4 ohm here. Now look at next one here. So something interesting. So in this third circuit, here they mention that 2 points. So here that point A is there, here that point B is there. So how to calculate that effect resistance between A and B here? So did you get any idea here? So how to solve this one? So this one I can solve by that symmetry method here. So folding symmetry. So upside down. If I fold that, so here R will overlap here, R will get overlap here, this R will get overlap here. So look at here. So just I will redraw this. So this circuit I will redraw. Here resistance R, here resistance R, here resistance R, and here also resistance R. This one is point A and this one will be point B here. Here I will take that folding symmetry. So look at here. So potential I will take it here. So between these 2 points, potential will be X here. So look at here. So here the potential is X, here also potential is X. So same potential means current will not get flow. Current will not get flow means these two circuit doesn't make any kind of affection. So here that potential is same between these two terminals. So X and X, there is no potential difference. If there is no potential difference means so that two resistance are dummy here. So now the circuit is simple. What is the nature of combination between R and R here? A to X and X to B here. So these two resistance are in what? Series combination. Instead of taking two resistance, or I can rearrange here. R, here also R. Similarly, R and R. Between that point A and point B. Instead of taking R and R, so these two resistance are in what? Series combination. Just I will take it as 2R here, and here also same thing. So instead of taking two resistance, I will take it as single resistance. So that is 2R. These two are in parallel combination. So 2R into 2R divided by 2R plus of 2R. 4R square by 4R. So what is the effect resistance here? R ohm. What is the effect resistance in this case? Effect resistance is R ohm here. So in order to solve this kind of circuit, just we will take the 2 points here. So for example, at point A, I will take potential is V. At point B, potential is 0. Between the 2 points, I will take that, means I will rearrange the circuit here. If you rearrange the circuit easily, you can calculate the effective resistance. Okay, so now we'll focus on that, how to solve that infinite network here. So effect resistance in case of infinite network. So look at here. So this is one network here. So ladder circuit you can call usually. So in this ladder circuit or in this infinite circuit, so these resistance are arranged in such a way that, so here that infinite number of arrangement is there. So keep on that infinite number of arrangement is there. Then how to find that effective resistance between the point A and B, I need to understand here. So I want to find out that effective resistance between AB here. So in order to find that effective resistance between that AB, so for example, I will take that equivalent resistance or effective resistance between A and B will be X I will take. So for my simplification. So I will take that effective resistance between AB is X here. So here, in order to find out effective resistance between that A and B in case of infinite network, so just I will take that effective resistance between AB is X here. So or we can consider, or equivalent or effective you can consider. So effective resistance between AB is, so effect resistance between AB is X here. So I will take that effect resistance between AB is X here. So now I will find out that value of X here. So in order to find out that effect resistance between AB, so I take it as X here. So now I will make one consideration here. So for example, I will take that, so similar pattern here or regular pattern I will take. So for example, so look at here, so this one is R, this one is R, similarly R term is there, R term is there, R and R. So repeating network I will take. So I will take that repeating network. So these type of network will get repeat here. So here and here, here and here, here and here. So these type of network will get repeat here. I will skip that first network here. So for example, first step or first network I will take, I will leave out here, and effect resistance I will find out here. So look at here, I will take out, leave that first repeating circuit here. So I will take that, leave first repeating network. So I left that first repeating network, and remaining repeating network resistance I want to find out here. So look at here, here infinite number of resistance are present here. Out of infinite number of resistance, first repeating network I will leave out here, and I want to find out that what is that effect resistance remaining network here. So just I will take out one repeating network, and I want to find out that what is the effect resistance for that remaining circuit here. So that for remaining circuit also I will take it as X only. Why? Because out of infinite number of resistance, so one pattern I will take out here. So remaining circuit is also infinite only. For example, infinite of -1, so that will gives infinite only. So listen here, here that infinite patterns are there here. Out of infinite patterns, first pattern I will take out here. Remaining pattern effect resistance I will take it as X only. So why I take it as X means, so for example, so in that of C, so you can take that one drop of water, so it doesn't affect that, water drops are infinite only. In the similar manner, here infinite circuits are there. In that infinite circuit, first I will take that one pattern I will take it, means I will leave that one pattern, and remaining pattern effect resistance is also X I will take it here. So why I am taking X means, so for my convenience I want to find out that X value. First I take that effect resistance between AB is also X, and in that second step I am taking that I will leave first pattern here, and all remaining pattern effect resistance is also X only I will take. Why? Because in case of X number of resistance, means in case of that infinite number of resistance, if one pattern is leave means, so that resistance will be infinite only. So that is what, so I will take that effect resistance for all these pattern is also X only. So I given one example. In that ocean, if you take the drop of water, it doesn't make any affection. So in the similar manner, in that infinite circuit, if you take that first part means, so remaining part of effect resistance is also infinite only. So for that purpose I took that, so one pattern I will leave, and remaining pattern effect resistance I will take it as infinite. So instead of writing all these infinite resistance, so its value I will take it as X. So for my convenience, so this resistance also I take it as X only. Why? Because so infinite minus of 1, it gives that infinite only, or infinite plus of 1, it will gives infinite only. So out of that infinite number of circuits, so just I will take out one circuit, and remaining circuit effect resistance also I will take it as X only here. So now I will simplify. What is the nature of combination between R and X here? So leave the first repeating network, and remaining network having effective resistance, effective remaining network having effect resistance is X only. So instead of taking infinite, so just I will take it as X here. Now R and X are in parallel. So these two resistance are in parallel. Instead of taking 2, just I will take it as 1. So look at here. So R1 into R2, R into X divided by R plus of X. Instead of taking 2, just I will take it as single here. What its value then? So its value is R into X divided by R plus of X. Now look at here. What is the nature of combination between R and R into X divided by R plus of X? These two are in series here. Now look at here. R and Rx divided by R plus of X are in series. So now I want to find out that effect resistance between AB. So between AB, these two resistance are in series. R of AB, so that is equal to R1 plus of R2. R1 is nothing but what? R plus of R2 is nothing but what? R into X divided by R plus of X. So look at here. Effect resistance between AB is also, I took it as a X only. So instead of taking R of AB, I will take it as X here. R plus of Rx divided by R plus of X. Now I will simplify this equation. So X is equal to R into R plus of X plus of R of X divided by R plus of X. Okay. So just simplify this equation. X into R plus of X square, it is equal to R square plus of Rx plus of Rx here. So one Rx term will getting cancel out here. So one Rx term will getting cancel out. So now look at here. So I will rearrange here. X square minus of Rx and minus of R square. So it is equal to 0 here. So now I got that equation, x square minus of Rx minus of R square, it is equal to 0. From the quadratic equation I can simplify that, and finally I will get that x value here. So look at here, finally I want to find out that x value here. So in order to find out that x value, so shall I rub it here? So what is that formula here? So that x is equal to minus b plus or minus of square root of b square minus of 4ac divided by 2 times of a. So I will use that same formula here. So if I use that same formula, I will get that effective resistance here. So x is equal to, b means what? So r here, so minus r, so minus into minus what? Plus here. So plus or minus of b square, so that is r square, minus of 4, a is equal to 1, b is, means c is equal to minus r square, minus into minus plus here 4r square divided by 2 into 1. So look at here, r plus or minus of, so square root of 4r square plus of r square, 5r square by 2, or x is equal to, so finally I will get that answer here. So x is equal to, look at here, where x is equal to r plus of root 5r divided by 2. So or I can take that r, if I take that common, means 1 plus of root 5 divided by 2. So negative value is not possible, so just I will take it as positive value. So this is the effect resistance between the terminal AB. What is the effect resistance? X is equal to R into 1 plus of root 5 divided by 2. So this is the infinite network. So I want to find out that effect resistance between the point A and B here. So look at here. So there is a slight change from that previous example. In that previous example, here one resistance is there. So now here that resistance is not there. So that is the only one difference. So what is that first duty? So my first duty is to take that effect resistance between AB is X here. So what is that first step here? In that first step I will take effective resistance between AB is, so effect resistance between that A and B is X only. For my convenience, I will take that effect resistance between AB is X. So second step, I want to find out that repeating network here. So in this given network, which network is act as repeating network? So listen here. So this is resistance R, this one is resistance R. So this two means these two pattern will get repeat here. So these two patterns only, sorry, here that resistance terminal is not there, sorry for writing this. So here there is no resistance. Okay, so listen here, these two patterns are getting repeated only. So these two patterns are getting repeat in this circuit. So if these two patterns are getting repeat means, so look at here, R and R, so R and R, R and R, so these pattern will get repeat up to infinite stage. So I will leave that first repeating network. So what is my duty here? In that second step, leave that first repeating network. So leave first repeating network. So leave that first repeating network, and remaining effective resistance is resistance is. So look at here, if I skip that first repeating network, so for remaining repeating network, effective resistance for remaining repeating network is also X I will take. Why? Because out of infinite circuit, if I take out only one pattern means, so remaining pattern will give that same infinite opposition only. So look at here, in case of that, taking that in that second step, I am leaving that first repeating network here. If I leave the first repeating network, remaining repeating network having resistance is also X only. Why? Because out of infinite number, if you take that single quantity means, so that remaining thing is also infinite only. So for that purpose, so I will leave that first repeating network, and remaining repeating network having effect resistance is X only. So it means, so instead of writing all these, so just I will take it as single value. So its value is X here. So that single value I will take it as X here. So that single value is X here. Now look at here, instead of taking that n number of repeating network, just I will take its effect resistance is X. Now what is the nature of combination between R and X? So these two are in series combination. R and X are in series combination. So what is the nature of combination between R and X here? R and X are in series combination. R of S is equal to R1 plus R2, R plus of X here. So look at here, instead of taking two resistance, I will take it as single resistance. What its value here? Its value is R plus of X. So now I want to simplify that. So this resistance I will replace here. So now R plus X and R, so these two resistance are in parallel combination. So next I will simplify here. R and R plus X, R and R plus X are in parallel combination. So these two resistance are in parallel combination means, I will take that effect resistance. Directly I will take R1 into R2. So R2 means what? R plus of X divide by R1 plus of R2 here. So R1 is R only, R plus of R2 means what? R plus of X here. So this is the effective resistance here. So instead of taking these two, I will get that effective resistance R of P here. So look at here, instead of taking these two, I will take that effect resistance single here. So now I will simplify here. So effect resistance between AB, so that instead of R of P, I will take it as X only. Why? Because effect resistance between AB is, I will take it as X only. So that purpose I will take it as X only. So R square plus of R into X divide by R plus of X here. So I will simplify that. R into X plus of Rx plus of x square, it is equal to r square plus of rx here. So here one rx term will getting cancel out here. So here one rx term will getting cancel out. X square plus of rx minus of r square, it is equal to 0. Again I will solve this one by quadratic equation. So x is equal to minus b plus or minus of square root of b square minus of 4ac divided by 2 times of a here. So look at here, minus b, so that is minus of r plus or minus of b square means r square here minus of 4 times of a value is 1, c value is how much, minus r square, minus into minus plus here plus r square divided by 2 into 1. So x is equal to minus r plus or minus of square root of 5r square by 2 here. So plus 1 positive value only I will take it here. So if I take that only positive value means, so finally I will get that x value. So x value is minus r plus of root 5 into r divided by 2, or if I take that r as a common, so I will rewrite here minus 1 plus root 5 r, so I will take it as root 5 minus of 1 divided by 2. So this is the effect resistance between A and B in case of infinite network here.